this because I don't need that. Okay, I just want to confirm a couple of things real quick before I continue where we left off. If I go to my page, I'm streaming, perfect. Oh wow, they're playing an ad on my channel. That definitely does not go to me. That's interesting. Okay, let's see, hold on real quick. How do I do that? They want me to change my name. I mean the stream title, edit, I think so. Here we go. Title. This is actually I don't know. I need to go to videos and copy and paste. Audio's good. Okay, cool. Let me take this. This is the title, but it's part 4. So I can simply edit, boom, part 4, and then streaming game development. Yep. Community. I don't know, game development. Can I do that? Game development. Oh, I seen it. Yeah, there's a community. Yeah. Okay. Sweet. Did that. I think now that I did that, I got the achievements. Perfect. Now let's start the stream. I will close this, close that, and have the chat up. All right. Sweet. Okay, so today I wanted to focus on 2 simple things. I don't have too much time today to work more on this, but first thing I'm going to work on is if we were to click this enough times, you will see that eventually our goal will there it is, will get blocked into one of these and we can't no longer get it, right? And so I just want to do a scan. Every time that we move it, I want to scan to see what spots. Actually, we want to move it to a random location, and we check that location to see if it's free or not. If it is free, it can stay. If it's not free, it needs to move again. That's probably the easiest, laziest way to go about solving this problem. So let's solve that. However, before we do that, I also want to think a little forward, because this software, or I don't know what you call it, JavaScript embedded programs. Let's just say this program, this game, I'll say this game is called Dak Delivers Dank Pizzas. And so this blue circle will be replaced with the sprite for Dak, and then this red circle will be replaced with a sprite for the house that he needs to deliver the dank pizza to. And so all of these black spaces, these obstacles, will be replaced with houses. And so my question is, like, should I instead loop through all of the obstacle spots and then place the goal house there, because that's where he needs to deliver to, and they're houses that are static? Or should I just make the house magically appear anywhere out of thin air every time it moves? I'm thinking the latter, just because it's easier and I feel like it'll add more challenge, versus if it's just these static spots, and then I'll have to rewrite how he collects. Yeah, we're just gonna keep it that way. All right. So first things first is I need to hold on a second. I need to open up that. Let me move this over here. I need to open that up. Where is it located? It's located in U, and then U, and then delete that because I don't need it. Shouldn't be doing this right now, but whatever, clean up a little. Cool. And then here, and then here, and then here. Open that up. Where you at? There we go. Visual Studio Code. All right. Dude, I tell you to download Git. You do this. Oh yeah, that's right. That's what I'm doing. Okay. So what are we doing again? We want to prevent this from happening. So first and foremost, let's look at the change move goal. So goal X and Y will equal what? Oh, because off. Okay. So off are randomized. L and W. What does this return? L and W, what is that domain? It's going to be 16. Okay, so that's how we can check if we use L and W, right? So if we can do print just to see if this works correctly. We can do print. I think it's called local. I forget what it's called. Loc array. I think it's called loc array. And then is it? I think it's width. Oh shit! I forget how we do this. JavaScript's so confusing because I can't just do equals 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 equals. I don't think I can do it like this. This is free. This will give me a true false. Let's just because I don't feel like going through a bunch of code to see how to do this properly. Let's just see if this works. If this works or not. But I do want to check if I'm doing this right. Yeah, I'm doing this right. J is W, and then I is length. Yeah, okay. So I'm definitely doing that right. So let's see if we can, if this pairs up to an array of integers. Let's say go. Oh, it crashed already. Wow. Wow. Alright, well, let's see what's going on. Why is it crashing? Open our console. Move goal, obviously. 82. Line 82. Okay. Alright. So it doesn't like that. Why did that just do that? Why is that surrounding it? I want to replace it. Oops. Alright. Still giving us problems. Okay. I'm going to comment this out. And I'm going to rethink how I do this. Let's see. So, what if we change instead to if this is still going to give us an error? Yep. Cannot read 16. Oh, duh. We need the off X and off Y. Of course. We need the off X and off Y. And let's go back. This is going to be nerves. Let's go back to our original test and do if so, then we'll just do print. Print success or sick, whatever, that's fine. Let's try this. Oh, well, that paired. That was awesome. That was awesome because it should have print sick. Wait, never mind. It's not printing sick either way. Free or not free, it's not printing sick. Okay. I don't know if we remove one. Yeah. I'm checking for if it's free. And it's printing nothing. Alright, it's taking very long. Come on, just please. There we go. Alright, so we still didn't get the print. So how about we do this? How about you tell us what you see? Right? Just how about that? Alright. So it's saying free, free, not free. See, now this is what's so annoying. I mean, what's his name told me yesterday what's going on here. So thankfully I wrote a function for this. What's it called? Check. I think it's called checker. I think checker. That with this. And then I can do if not checker. Maybe. If not checker, then print. So if not free, check this. Let me just confirm that this is the right function. Checker, where you at? Yeah, in regular C#.NET, you can just hit F12 and it'll take you straight to the function where it's defined, but in JavaScript it's different, and that's really annoying. Wait, where is checker? Hold on. Oh no, it's R compare, not checker. It's R compare. Alright, so if not, so let me see, F12. Yeah, cool, it does it in here. Takes me straight to the function, returns a boolean. Right. Perfect. If not free, then print sick. Alright, this should be, yep, it printed sick on load, but we want to just make sure that it works correctly by, sweet, perfect. Looks like we got exactly what we want. Boom, 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 boom. Come on, get stuck, 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 just so we can, I mean, we already know that it works, I just want to, there it is, sick. Alright, sweet, perfect. So now that we are able to identify when it is stuck, we can just say, if not free, then we just do this over again. Then we'll just say, off, oops, just copy this and do it over again. I should ideally turn this into a function, but it is fine. It's not really necessary. Oh, shit. So now it should never get stuck. Actually, let's print, just so that we know that it was stuck and we don't chase the rabbit's tail forever. So if we see a print that says rabbit's tail in our console, then we know that it's stuck, but then it moved again. Right, so let's just wait for the rabbit's tail to show up in our console. Come on, rabbit's tail. Come on. Come on, rabbit's tail. Wait, let me just confirm that I'm streaming the right screen, because that would be annoying. Alright, perfect, I am. Come on, rabbit's tail. Where are you at? Oh my god, we're literally chasing the rabbit's tail trying to find this. Unless it... Oh no, that's not possible. Come on! Rabbit's tail, where are you? This is insane. This is insane. I have 40 points. Oh my god. Oh my god. Alright, I'm about to reload because this is getting crazy. I have 50. I will reload. Okay. Hold up. Before we chase the rabbit's tail again, Let me just make sure. I'm just gonna move this just to be safe. Here we go. Let's do this again. Oh wow, of course. This is insane. I don't understand why it's not printing. It should. I mean, it's cool that it's not getting stuck at the same frequency that it used to, but I kind of want to see that print in our console just to be sure that, you know, our order of operations is working correctly. There it is. We finally caught the rabbit's tail, damn it. Sweet. All right. So this lets us know that it's working as expected. It collided and then it got a new, well, let's go in the code. So it compared, it found that the spot was not free, and then it printed a rabbit's tail to the console, let us know that it wasn't free. We are done chasing the rabbit's tail, and then it re-scrambled a new position, and then it moved it to that position. Perfect. That part is done. Next, what I want to tackle is I want to kind of get started on the whole scoring process that I'm going to use for the neural network. And then if it's not too daunting, I also want to get to some spriting. Maybe start replacing some of the sprites, maybe make those and whatnot. Perhaps. We'll see how I'm feeling in a few minutes. But for the scoring, this is the idea that I had. So I want to optimize on the best route possible, so kind of like an A star pathfinding algorithm, but with a neural network. And it wouldn't be the most optimal way if I just had, for example, score 0 and then you collect 1 and you get plus a point. That's not optimizing for the best pathfinding, because there is no difference. If that is there, if the goal's there, I'm here. My starting point is here. If I go this way and get it, there's no difference than if I start here and I go down here. I go all the way over here. I go here. Then I come down here. I do a loop. Then I go up. And finally, I collect it. There's absolutely no difference based on the scoring convention. And so one thing that I want to do is I want to penalize every single movement. So every move that I take, I need a minus a point or so. And so I was thinking, just to keep it easy, I could do whole integers and like every point is plus 10 perhaps, and then every movement is minus 1 maybe. Or I could just keep them 1 point per collecting of the score of the goal, and then maybe minus, like, I don't know, 0.1% or something like that. So it becomes a floating point score. I don't know. I always feel like whole integers are easier to work with. So that's what I'm going to do. I'm going to give plus goal. You know what? This is probably a better way to think about it. How about per delivery, you get like $25, and then per movement, you have to. It's like $1 a gas. I think that is actually a really good convention, and it's easier as far as like communicating neural networks is concerned. It makes it easier to do that, to accomplish that. So that's how I'm going to go about doing this. So let's change the scoring to, where is that? I have no idea where to find score. Here it is, score plus plus. So let's do score plus equals 25, and then every movement, which is going to be move guess. Well, there's a, let's see. Give me a second. I'm not used to. move, here we go, these are what I'm looking for. So here, I'm going to do score minus minus for all of these. Right? Now, if we go in, we will see we'll go into the negatives, but you get a score and it goes up. Right? And now, you can see that taking the shortest route is the most optimal way to get the most amount of money. Right? Versus if I were to go down here and come all the way over here and go through here, take a loop and blah blah blah. I just wasted all my money on gas just to get that one. I could have saved a lot more money by taking the shortest route. Right? And these scores are how we're going to judge our neural network when it comes to implementing the genetic algorithm. And it's going to give us the most optimal pizza deliverer. Cool, it's coming along. So that was a lot easier than I thought it was going to be. What was one more thing that I wanted to add? I don't quite remember. Before sprites, there was something I wanted to add. Don't quite remember. Oops. Alright, no biggie. No biggie. No biggie. I'm curious, if we let this run with the random walk, how would it do? Of course it'd do terrible. I can't wait to implement the neural network and see it get better and better over time. Oh my god, this is, as expected, it's super terrible. Alright, enough of those shenanigans. Okay, let's before I end the stream, let's look at a little spriting. Let's see what's the deal with that. Oh shit. Oh yeah, that's what I wanted to do. I wanted to, instead of having the agent get blocked, I want to see, warp them, wrap them. I want to wrap them around. That definitely I want to do. Because in this situation, I'd still be able to get to the house by going up, like so. I mean, it doesn't completely fix the problem of that. We're going to have to come up with another solution for that later. Because if there were a block here where the player's at, then there would be no way to get that. But in this case, it would at least, it would increase this problem. It would, what am I trying to say? It would decrease this as being a problem a bit if I were to add wrapping. So let's look into that. Ideally, if we turn on debug, you can see that, for example, this spot is 2, 0, and in order to 2, 0, wait, 2, these are all 2s, right? So in order to wrap it, I want to transform this from 2, 0 to 2, 15. And the simple equation for that is going to be just make the y to be whatever the length is of your map. It's really that simple. Right, okay. So I'm going to enable this only on the up, on move up. Alright. Let me think about this for one quick second. Check move up. So where's check move up? F12. Check move up. So on the check for the move, if it can move up, we see if the y is greater than the C size. So that means that that would mean that it's y is greater than this. Wait. Y is greater than C size. Up. That doesn't make any sense. Y is greater than C size. Y is greater than C size. What is C size? C size is 32. Oh yeah, actually that does make sense. Y is greater than 32. So here, this is 32 is this line right here. So if it's greater than this, then it can move up. If it's not greater, if it's even 31, that means that it's on this side of the line, and we don't want it to go over the map. We don't want it to overshoot. So if y is greater than 32, or whatever the C size is, and we compare to see if the whatever before is not an obstacle, then we return true and it can move. So we need to add another else if y is less than C size, right? And we can do instead of the age, and this doesn't matter, we can do, how can I get that? Length minus 1, I'm pretty sure. Oops. Go back. Length minus 1, then we can do, oh shucks. This returns true. This is just a check. Oh shucks. Okay, so we have an interesting situation here. Okay, wait, before we move on, let me explain what this is because I'll probably forget otherwise. So else if the y is less than C size, which is above this line, if it's above this line, and if the position of the same x it's on, right, which is going to be, if you see x all the way through on this line is 5, right, so same x and the length minus 1, which the length minus 1, the length variable is 16, and because we started at 0, it's shifted minus 1, so you just do minus 1. So that's checking all of these. So if before this and if this position is free, that's what it's checking. Then I can't return true here. I don't think. I can't return true here because what happens is when we check move up, where is that at? It's at the bottom, I guess. When we when we check move up, then it will move up, and that is simply just saying to minus whatever size it is. So that will go over the map, which is what we don't want. So we need to figure out a new convention. We need to change this. So if check move up maybe we can move this check. Yeah. Let's move this check. Into here. Ah shit, but then it won't pass. So we need to keep that there so it returns true. But we need to also duplicate. This is a very lazy way to go about doing this. I don't recommend doing this. I would, if I were you, kind of do your best to think about this ahead of time so you don't have to write lazy code like I'm about to do. But if, I guess I don't need two ifs. I guess I don't need two ifs. If this, checking if before, I already explained that. So we check for that spot to be free. If it is free, then y equals, or can we do y, I guess y plus equals C size times what? L minus 1. I'm going to encapsulate this in parentheses just because it clears up all ambiguity. Sometimes the computer likes to infer things on its own, and this lets it know exactly what I want to do in order, as far as order of operation is concerned. Right. Else, when we do our standard. This should work. Let me think about it real quick. So we return true if. Alright, that sounds redundant. I'll optimize this in a minute, but this part sounds redundant. No, it's not. It's not redundant. Okay, so we check if the spot above is free and if the warping spot is free. The wrapping spot, sorry, the spot that you'll wrap to is free as well. And if it is free, then return true for it can move. And then in the actual move, we check. We don't need to check this. We just need to check the position. So if y, we'll just keep this for now. But this, all we really need to do is check is if it's on the outskirt or not, which I'll change that in a second. But for now, we're just checking again if it's free. Yeah, this is actually bad. This is actually not good at all because it doesn't. Okay, so if y, are these, what does y represent? Y minus c size. Can I do y equals 0, or is that equals 0? We're just gonna do for now. Now I'm gonna print this. I'm gonna print this just to see what the actual values are. Okay. Oh shit, that's a checkmate. Alright, so up 48, 16. So 16 is what I'm. So if y equals 16, I don't know if you need 2 or 3. I don't really fucking know how they do their Boolean operators, but I'm gonna do 3 because that's what I was told. Okay. Oh, there we go. Oh, we got an error. Okay, so this part worked. This part didn't want to work for some reason. I don't need you anymore. We got that value. Else. In fact, I can move this out. And agent y. Oh, okay. So yeah, I need that out as well. That's probably why I got an error. Nope, that's not why we got an error. Okay, it's working, but let me see. Yeah, it's definitely working. But then we get an error on that, which is interesting. What are we doing wrong here? Agent YY. Oh. Because agent YY is not on. It's not the same anymore. How do I fix this? I need to print this so I know what's going on. I need to print this because I don't remember what agent Y is doing. 8.7. So is this corresponding with our map? 7. Wait, 9. What the hell? 6. 6, x is 5, 4. Okay, yeah. So this is corresponding with our, as you can see, our y. This is telling its location. So what we need to do is when we go here, we need to update because it's still saying 0. Okay. So then we need to say agent y equals L minus 1. L minus 1. And this should fix our problem. There it is. Perfect. Perfect. Now we can. This shouldn't be able to wrap. It can't wrap. Perfect. Perfecto. And then if we go over here, this one shouldn't wrap either. Oh man, this is awesome. Alright, so now we just take the same convention that we wrote for up, and then we just use it for all the other directions as well. I'm trying to think if there's anything that will prevent the neural network from being able to learn from this. There shouldn't be. No, there's not. Alright, so now let's take that same convention and repeat it for all the other ones. My voice is on a very cracky state tonight. So this is, we're going to do the opposite. So if x is less than, and let's see, x, so then we need w, but here, and this is agent y. I'm not putting full thought into this like I should be, but this should work. Y is less than, if we're going down, then this is simply 0. Simply 0. Right is going to be 0. And left is going to be width minus 1. Else less than, or greater than rather, sorry, and then this is 0. And then we need to come down to our actual moves. And shucks. How do you format this? Just format yourself so you're pretty. Format. What just happened? Ew, JavaScript format is ugly. I hate this. Selection. Oh, that's a document. Is Alt-Shift-F. Okay. Alt-Shift-F. That's the entire document. JavaScript, you're ugly the way you do this. I hate this. Okay, whatever. I'm a grown man. I can figure this out. I can deal with this. Alright, so let's now copy this convention. For up is 16. Up is 16. And then that means left is 16. So we'll start with left. Left is 16 for x. Oh, actually, and then put new code, and else original. The code I want to do is going to be this one for x. X, and this is W, and this is W. Okay, if I did everything right, then up and left should work fine. Yep. Down is different story. Let's get in down and right, and then we'll be good. We'll be good to go. Alright. So you're of course going to be else original. All right, let me just get that started for both, because that part I know. Boom. All right, so let me think about this. So right, so left, this is going to be the opposite of left, so I can just copy this, copy that, and then I can also copy this, and squeeze this into here, and this is going to be, let's see, so if x equals, this is going to be what, c size, what is that, 16, this line is going to be, wait, actually 16 shouldn't be, I shouldn't use 16, because then I break the scalability. I need to do c size divided by 2 instead of 16. So let me just change all that real quick. Divided by 2, c size divided by 2, and then c size divided by 2. I think that's all the places that I used. I don't think I used it in here. Yeah, cool. Cool. And I was doing right warping, I'm pretty sure. Yeah. So c size divided by 2 times, this is going to be times w. Pretty sure that's that line. I'm pretty sure that equation represents this line. And if so, then x, we can just do minus, yeah, we can do minus c size times, yeah, and then agent x equals 0. Pretty sure this is, can't leave it like that. Alright, that's fine. Pretty sure that the right should be functional now. Nope. At the console. Made an error somewhere. Let's print out that x, see what the actual location is. Let's print. First is going to be actual x, next is going to be agent x. Alright. Actual x is 48. 48. Right. Then this is 496. So let's see if my equation is right. I said, what is it? It said 16 times 16. That's 256. What am I looking for? I'm looking for 4, so maybe it's 32 times 16. 512. That's minus what? 16. That's minus 16. Okay. So the equation that I'm actually looking for is W times C size minus that. That's what I'm actually looking for warping. Let's see if it works before I think about why that is so. Yep, that is the equation. I was thinking about why that is so. I don't quite understand on top of my head. So first and foremost, W times C size, that is going to be the entire size of the map. I can move this. I can remove that. That's the entire size of the map. They're made. Each square is made up but the same size of the actual agent deck. So that's times the length, which is 16 times 32. That's what this is. That's what, 512. And then we have to minus half of its size, right? Because there's an offset. There's an offset. So here is the location for x is 496, and without the offset, if it were to be 512, then you would see half of the circle in this square, and then the other half you wouldn't see. That's what 512 equals for this. So I need to minus that offset. Cool. That's what that is. Sweet. It works. Now let's get that working for, what are we missing? Down, and then we'll be good to go. To do that, I'm actually going to take this. I'm going to copy this because it's the exact opposite. Right, okay, so this is going to be instead length times c size minus the offset. I guess just for redundancy's sake, we can do that. And then we're going to minus c size and then agent y equals 0. Else we do what we always do. Alright. See if we did this correctly. Yep, I can go back. Wait, hold on a second. Yeah, okay, cool. Sweet. And we have complete wrapping for this game. And the neural network will learn. Whoa, I just went straight through that. Whoa, I'm going straight through these now. Whoa. Well, at least on the right. Only on the right. I'm going straight through these. So I made an error for the right. Oh, and down. I made an error for the right and down. Okay. No biggie. But as I was saying, the neural network will learn how to take this wrapping into an advantage. For example, if it's down here for whatever reason, it'll learn to just go over one and then down. Just because that's, neural networks are magic, and they can learn things like this. The data will tell it exactly what to do. But we have an issue with going through objects. And let's see why. Down. So if zero, wait a tick. Actually, can we test for that? Okay, so that for sure still works. Where's this error coming from? I don't think it's coming from here because returning true for can move. Yeah, it's not work. It's not there, right? Agent X plus 1 is returning true. Okay, what if I reload this and then try it? Okay, I can do it from the start. Where did I make this error? God damn it. First of all, I want to remove that print. That's giving me a headache. Right, move right. Else. I swear it's the smallest errors that will just make you pull your hair out. Whoops. Right and down, up and left, I can't. right. Wait, right. Now I can't do right, but I can do down. Can't do right. I can do down. Can't do right. Can't do right there. Can't do left. What in the hell? Alright, I'm actually going to take a quick, short little break and I'll be back. All right, let's drive this home. So, right sometimes doesn't work. That's more annoying than it 100% doesn't work. So there are a couple of tests that I can do. One of which is I debug to see if it's checking if this is free or not next to it, which I think I'm gonna do. I'm gonna do that first. Start off simply. So every movement. Every movement. I simply want to print if the next is free. And that is arg compare and then loc array, I'm pretty sure, agent x and agent y. Okay. With free. Print that for me. Okay, this is for right, but I guess right and down is all that really needs. So right and then down. Alright, let's see what we got. True, it's free. True, it's free. True, it's free. And then false. Which is, so it's a little delayed. It looks like. Yeah. It's a little delayed. Okay. Just for curiosity's sake, what if I move it to the left? How did this happen? False. No. Oh, that's right, left, not up. False. No. Oh, there is no false. How did this happen? I think I'm in the wrong spot for this. I actually need to be in check move right. Or wait, yeah, check move right is where I should be. So when you check, instead give me that, right? True, true, true. One after, false. What? So what I need is agent X and agent Y. I think. Ah, shit. Lowercase. Lowercase. 0, 0, and this is saying that. I guess I need to do +1. 1. Right, it's true. 2, 0 is true. 3, 0 is not true. 3, 0 is not true. What happened? How did this happen? Oh shit, that's because I'm checking for the actual location. Right, that's why. So not true, not true. I mean true, 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 not true. Wait, what? False. Okay, there we go. So that is working right. We'll do it again. False. So it shouldn't let me through, but it does. And the reason for that, okay, let's check these. If x and not, and this is not equal obstacle, if next is not equal obstacle, this is greater than C size. X is greater than C size. This is probably where this is going haywire. Because if we remove this, then I'm sure it'll work fine. We lose wrapping, but it'll work fine, right? Okay, so this equation's off. Let's see what we're doing wrong. If X is greater than C size and the first location on the X in your current Y is not an obstacle, if X is greater than C size, right, so if X is greater than, I think this is what I need this one right here. And this should be divided by 2. I don't know why that's full. I'm pretty sure this should fix it. Yeah, fixed it right. We should be able to work still. Nope, can't work. Okay, well at least that fixed that. And let's fix the warp. What's going on with the warp? Is it really the full C size? No. I'm confident it's divided by 2. I don't want to think of logic at the moment. What error are we getting? Check move right. 172. Oh, let's give us an error on a print. Who cares? Nope, this is not wrapping. Okay, there we go. And we can't go right. Okay. Okay, cool. So just because of the person I am, I have to think about this. Why is it the full C size? So if X is greater than, okay, W, which is, let's see, 16 times the size, 16 times what? 32, that's 512, minus 32. What is that? 4. I suck at math. Who cares? That's 480. Okay, 480. So if X is greater than 480, 480 would be. I just have to understand this. So I'm gonna go print, just so I know, print X. Let's see. Why are you not printing X? Why are you not printing X? You should check regardless, so it should print X. There we go. I don't know why after, anyways. So this is 496. So if it's greater than, I don't know. Who cares? It's working. It's working, or at least it was. Yeah, it's still working. All right. Cool. Versatilis. What's going on? Welcome. Welcome, welcome. That's the layout I see most often in languages that use braces. The layout using last night. It was making me a bit itchy. By the way, someone had me distracted for the last 10 minutes. I didn't even know that you were here, man. You're covert. You're a covert ninja. Yeah, because that was quite a while ago when I was talking about the braces. Yeah, I don't know. I guess because I grew up writing in Game Maker, I like the other way of brackets. I like doing it like this. Just because it's easier for me to read personally, but I mean, hey, I respect this way as well, I guess. Okay, so the wrapping works for all of them, except the only problem we have is the down collision. We just need to fix that, which we've got to do the same thing that we did, which is this part for down. So C size. Yeah. This should fix it. Simple as that. Simple as that. Yep. 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 Cool. Sweet. And we can still wrap. No errors. We wrap all around. Okay. Okay. All right. All right. Now let's try and get a nice score. Let's see. Oh shucks, this is interesting. Sweet. Get down. Oh yeah, this is cool. That was not the most optimal way to go about getting that, but I did it. This wasn't either. Okay. Alright. Boom, boom. There we go. Boom, boom, boom. Now, do I think a timer is worth it as far as inputs? Let me think. I don't think it is, because I have this slider in which is going to determine how fast it goes. Well, maybe it is. Maybe it is, because if they take two different routes, no matter what the speed is, one obviously is more optimal, but their score will also reflect that. I mean, I'm just trying not to overfit the network. It's a problem for another day. But for now, I think this is a good place to stop. We've been streaming for 1 hour and 10 minutes. That's good. That's good. And next episode, I'll get into some sprite work maybe, or just continue building a neural network. I don't know. But I'm happy for this progress. It is time for me to switch gears. Sweet. If you happen to join this stream and you were silent like Versatilis was, thank you for joining, Versatilis. It's always a pleasure to have you join the stream, my man. I'll see you guys tomorrow maybe, or the day after or something. But I'm out of here. Peace out, guys. Thank you for everything. All right, I'm out.